All right, here we go. Now we are in chapter 10, which is statistics, data, and we're going to be going into 10.2, which is it's quite a few uh, PowerPoint slides. So I just want to make sure you're aware of that. I might go through a few of them kind of quick. Just go ahead and pause it, read the slide, and you can come back to it again as you look through the video. So go ahead and get to our PowerPoint. All right, so chapter 10, data analysis, statistics and introduction. So we are in 10.2, okay? So things we're gonna be talking about, okay? Difference between categorical and numerical data, what a dot plot is, a stem leaf plot is, histograms, bar graphs, the differences and similarities, and how to deal with circle graphs, okay? Now, all these you've probably seen before, maybe not the terms, but that's kind of what we'll kind of go through. Okay, so in data analysis, okay, it refers to it says it's in more informal approach to statistics. It is relatively a new term in mathematics. Okay, so being able to go through data analysis, this is a term. Your guys going to be teachers. They want you to do data analysis. Sometimes it's information that you might like, or that might be helpful. Sometimes it's not, but it is the new thing these days is to go through certain data, see how things are working in your classroom. Your data analysis you're going to do for your class and how you're teaching is going to probably be very, very helpful for you. Whichever district you might be working for, they may give you some stuff you may or may not like. It might be somewhat helpful. There's always something in some of the good data. It does depend on some of the questions they do give you. And then statistics once referred to numerical information about information that we are trying to talk about political territories. You don't need to know that's Latin statistics. All right. So it's data and observations such as measurements, genders, survey responses, things that you go out there. Those were those questions were for that we talked about the other day. Okay, it's all that collection that you do. The statisticians take the data from small portions of a large group in order to determine information about the big group. Okay, this information is used to make conjectures about the entire group. Okay, now the smaller the group, the more of the group you need to take a data on. The bigger the group, it's almost possible to get that. So you hope that your data and your questions are good enough to reference that whole group. Okay, so describing data frequently involves reading information from graphical displays, tables, lists, and so on, which is what we're going to talk about today. Okay, and the next time. So category data is data that represents characteristics of objects, okay, individuals and groups such as black or white, inside or outside. It's going to give you some just different types of categories. And then you have numerical data, which actually use numbers, okay? It says in grade school, students may ask whether or not it's difference in the distance that girls and boys can jump. So you're putting a value to it. Okay. I'm a numerical kind of data person. I can tell that by watching the Olympics. I like the data that comes from an actual numbered information, like a long jump, like they're talking about. You get actual distance. Categorical data would be something more like in gymnastics, possibly that they're taking information and giving some sort of information. All right, so let's talk about some of these kind of data things. One is what's known as a pictograph or pictograph, however you want to say it. Okay, I sometimes uses tallies. Okay, but that information that you are trying to display is going to use a symbol in it. Okay, and it should resemble some numerical value normally. These are ones for really elementary schools. Okay, the younger the kid, the probably more pictographs you're going to use. Here's an example of one. Okay, in the pictograph, you're going to have a symbol or an icon that represents some amount of that item, some quantity. Okay, you must have a legend to go with this. So here's your legend right here. Okay, so in these legends, oops, So legend is here. You have to have this legend, okay? That is important, otherwise you won't be able to tell what it's about. Okay, the legend gives how much each book is worth. Okay, so July, you have 4 books. That would be 4 times 10, that's 40 kilograms. Now, you can also have partial of that picture. Now, this is what makes pictographs nice, is the pictures are nice, the kids can understand it, but you are limited to how you can deal with, here half a book. It would be impossible to tell a fourth of a book. Okay. All right, says the number of students in the teacher's 5th grade class at Hillview is depicted in both this table and then in a pictograph. Okay, so again, we are looking at legend there. Each picture is worth 5. Okay, this is great using people. They understand what a stick figure is, and that's how many people. Okay, so you have 5 students, so Mr. Ames or Mrs. Ames or teacher Ames has 4 times 5 is 20, right? Okay, here that would be 25, right? Now, stick figures are great, okay, but just do be careful. Okay, you would not want to do a half a person. Okay, you wouldn't want to do a half a person this way. Okay, so in this case, you would only use a picture if you had, some value, because if they made 10, how do you represent 5? A half a person? That would look weird. So you'd have to be very careful on how you decide you're going to use what picture you're going to use. All right, now dot plots. So dot plots, or they also called line plots, it says give a quick and simple way of organizing numerical data. They are typically used when there is only one group of data with fewer than 50 values. Okay, it is very effective. Okay, so here you have 30 students and their test scores. Okay, so in a dot plot, we can take these 30 scores and reference them. Okay, by using a tabular kind of thing. Each X represents a person, okay, and their score. So notice 50 all the way to 100. Now, why they pick 50 is because the lowest score here is down at, looks like 52. Okay, so you're going to have different things that you can see. Okay, so when we'll talk about these here in a second, but let's go ahead and go with it, some of it. So we notice that's the highest, right? Okay, and then you have some low values of 170, 188, right? And you have this guy out here, which they call outlier. Okay, and you have gaps. You have it's an outlier because of this big gap. And in, I believe, 10.4, we'll talk about how we determine if something is an outlier. Okay, and then you have this, and then you have this gap right here. All right, so you have different things you can come across. Okay, now what other things can you find if you remember your old data? You can find mode. Which one happens the most? 82, right? Those are the ones we'll talk about mean, median, mode later on, but this one has mode. Okay, you can sometimes find averages, those kind of things for these. All right, so these are things it talks about. Here's your 52, your outlier. Okay, here's some of your high scores, and you have what is known as clusters. Here's a cluster, here's a cluster, and these are kind of all individual clusters. You can make them one big cluster possibly. Okay, so you have we talked about the gap too. So you have outlier, a data point whose value is significantly greater or less than the other. You can have an outlier that's way too high. Okay, clusters is a group of points. You have a gap, a large space between, and then mode is the one that happens the most. We talked about each of those. Now, same information, but under what's known as a stem leaf plot. A stem leaf plot has different parts to it, and it just organizes a little bit differently. So you have, this is my stem right here. That's my stem. Okay, and then you have these leaves that come off. Now, the way this works, you have to look at the legend over here. 9-7 represents 97. Okay. 11-3 would represent 113. Okay, so that's kind of how that works. Okay, remember the lowest score was a 52. Here's your 52. Okay, your highest score is at 98. 98. Now the nice thing about this is it does help you find where the stem leaf or the number line one, you might not see them all, but look at the 397s or the 482s. You can really see them. Notice they are numbered all the way in order. These have to be in order to make it effective. Okay, where do you have the most 80s? Right there. 80s is, or I said that wrong. Which grade was the most? Was your B's. You had a couple A's, okay, a bunch of C's, and only one failure. That's good. Nobody likes, you hate to have any failures, but one's not bad. Maybe they just had a bad day that day, okay? But I've used something like this, not extreme, not exactly like this, but it does help me know how many A's, B's, and C's. It brings it in a little bit clearer for you. All right, so in order, it says, in an ordered stem leaf plot, the data are ordered from least to greatest in a given row. We talked about that. Advantages of stem leaf plots. They're easily created by hand. I did them all the time before computers. Do not become unmanageable when volume of data is larger. It can get large, leave them big, it's kind of tough. No data values are lost, which is good, okay? Disadvantage, we lose information. We may know a data value exists, but we cannot tell which one it is. I've never had that problem, but they say it does. Okay, how to construct a stem leaf plot. Okay, and these you can kind of go through yourself. Find the high and the low values. That way you're not making a whole bunch of them. Notice it gave from 50 into the 90s, so you don't need a 4, 3, 2, and 1. You don't need 10, 11, 12 because you wouldn't have above 100. Decide on the stems. Okay, that's what we just talked about. List the stems from least to greatest. We talked about that. Use the piece of data to create leaves right of the stems on appropriate rows. If the plot is to be ordered, list the leaves from least to greatest. Add a legend to identify how you're using the stem and the leaf. Add a title explaining the graph. A lot of times we forget about the title. Make sure it has the title. All right, now, what's known as a back-to-back stem plot. Okay, so it works kind of the same, but you have a left side and a right side, two different classes, and their grades. Again, the lowest grades were in the 50s. The highest grade, look here, we have 100 in fifth period class. Okay, how do I know that's 100? Because it's this number and then one more digit, right? So this was the fifth period class over here we talked about. Now, if you look at second period class, notice we only have one A, 191. And notice the legend over here. It's backwards, right? Here's the stem, here's the stem, and here is the leaf, okay? Over here, this is the stem, and this is the leaf, okay? So over here, we have an 88, okay? If you go order, there's an 80, 82, 84, 85, 87, 88. Okay, notice there's 3 79s in this one. Not 97s, but 79. So it goes this way, it's read this way. Over here, it's read this way. It's pretty clever and pretty ingenious, actually. All right. Okay. So it says group of presidents in two groups: George Washington to Rutherford B. Hayes and James Garfield to Ronald Reagan. A little outdated because there's been, let's see, George H. Bush, Clinton, George W. Bush, Obama, President Obama, and now President Trump. So there's 5 presidents since they did here. Okay, and let's see here. However, none of them have died yet, so I guess it is pretty updated. Okay, forgot it's about the deaths. Whoops. All right, so this is the age that they all died in order. Okay, so we want to organize that, and we're going to use a back-to-back. Okay, so you would need to go back and see, okay, what's the youngest? The youngest, I believe, would have been probably Kennedy, right? 46. Here's a 49. There are no 30s. Oldest are in the 90s. So you're looking at 40s, 50s, 60s, 70s, 80s, and 90s. No hundreds. Okay. And then your least, right? Now, why do they have two groups? Okay. They have a first group and a second group of this kind of more modern kind of side. Okay. Which of the groups seem to have lived the longer? Okay. So when you make it, notice there's the 40s through the 90s. The early presidents, and then you have the later presidents, the second group. Okay. Now it says here, because the age difference varies from 46 to 93, the stem varies. The first 19 presidents are listed on the left. So again, early presidents and late presidents. What does this show you? Yeah, not a whole lot. That you have some issues with causes of death is one. But it is just statistics for you. It says the early presidents seem, on average, to have lived longer because the ages were in the high end, especially in the 70s to 90s, come more often from the earlier presidents. I don't know. Why do you think that is? That's what you would then determine. Less stress, more stress now. However, there's more older 90s, and there's 5 here. There's only 4 after the 70s, but a lot more 70s. 60s. Now, there are some outliers in here. If you think about the biggest outlier of all, is this 46, because he was assassinated, right? Okay. So that's kind of an outlier. The 49, I think he was sick or something. I don't remember. I'm not that much of a history person. All right. Says the age of the lowers end up more often from the later presidents. For the stems 50s and 60s, the numbers of the leaves were about equal. So, all right, frequency tables. A grouped frequency table shows how many times data occurs in a range. You've done this as like little tally marks. Okay, so you would use a frequency table when you have a range instead of individual ages or whatever the case may be. You have to have a range for it to work. And yeah, you can do this with your grades in school. Okay, remembering that the 5th one always is the slash that goes through. Okay, this again is about the deaths. There's the 2 49s and the 4 90s that were all together. Okay. But this is handy as a quick view of things. Characteristic frequency tables. Each class interval has the same size. In other words, 40 to 49, 50 to 59. It's the same number of years. The size of each interval can be computed by subtracting the lower endpoint from the higher. We know that how many data values occur within the particular interval, but we don't know the actual data. Okay, now what that means is the following. In this kind of category, there's 5 that died in the 50s, but you don't know what their actual age is, and that's what it's trying to tell you. Okay, as the interval increases, information is lost. Okay, classes should not overlap. Okay, in other words, you can't do 40 to 55 and 50 to 50 to 60. You can't overlap them. Histograms and bar graphs. Okay, so these look very similar. A histogram is made up of adjoining rectangles or bars. Bar graphs are not connected with each other. The bars are the same width, usually in both of them. The scale's vertical axis must be uniformed. And distinguishing feature between histograms and bar graphs is that there is no ordering that has to be done with bar graphs, where histograms have to be in order, which means histograms are probably more numerical about the histogram than the bar graph. Okay, here's that deaths of presidents again. Okay, this is a histogram. There is no gap in between. Okay, so they are set alone and they have to have some sort of range in their data. Okay, let's just preference this. This comes up a little bit later, but I'm going to talk about it now anyway. This right here. This is just in a bar graph and in a histogram. You have to use this because you're not using the ranges from 0 to 9, 10 to 19, 20 to 29, and 30 to 39, because mostly you can't be a president that young in some of them, and there haven't been any presidents those ages. Okay, so this is just a filler so that you don't have to have those others, because you're not supposed to have any gaps in a frequency table or histogram. Okay. All right, so let's go to the next one. Okay, here's a bar graph. Notice this is just, you're going to have your information on one side, okay, but on this side, you're not going to have the connection. There's no gap, and there's no range down here. It's just how many, what's the height of Tom, okay, height of Mary, height of Joe and Jane. Okay, now notice, so here you have the gaps. They're not going to be connected together. There's no range down here. Here is again that marking going the other way on the y-axis, the sideway axis. This is so that I don't need anything lower than 130. In fact, maybe even 135 would have been okay. Notice they go in fives to make it a little bit easier. And most of these you're just going to have to be able to read. Okay, double bar graphs. Okay, so double bar graphs will have 2 bits of information. Again, here you have the frequency. Later presence is in light blue. Earlier presence in darker blue. Now, if it was me, I would say do 2 different colors. It looks better for one. Okay, or you don't have to do colors. You can do little symbols that are inside. But in double bar graph, you're comparing the 2 different categories with their frequency. Okay, so you can connect those categories together. Okay, here's another one about shoes. It says the table shows various types of shoes worn by students in one class and approximate percentages of the students who wore them. Okay, so I have 1 dress shoes, 4 flip-flops, 7 Crocs, 3 loafers, and 14 tennis shoes, regular running shoes, whatever case may be. Now notice we have a percentage. How does that percentage come about? Well, you should be able to have a total, and you would be able to find your total by saying how many students are here. That's 10, 14, 15, so that means 29 students, right? So this number comes from 14 over 29. This one up here is 1 over 29. That's how you get your percentage, right? All right. Whoops. Let's clear those out. All right. So you also have what's known as these bar graphs, percentage bar graphs. So this whole thing equals 100%. Okay. So if you think about it, we can go through this again. So if this whole thing is 100, that means halfway has got to be, halfway is going to be there. I can't draw a straight line. Let me see here. Let me see if I can draw a straight line. All right. So halfway has got to be about there. Okay. So there's your halfway, which is, you can kind of get a little less than 48% and so forth. Okay. So you can kind of guesstimate some of those, and they're not the most accurate thing in the world. Okay. The table shows information about expenditures. And notice you have a range here of years. 10 years, 10 years, 10 years, 10 years, right? Materials and labors. So you have these stacked bar graphs. Okay. Labor and materials. Again, labor and materials. the same blue color or very different shades of blue. Not too bad on one of these. You can see them fairly well. But again, you could use two separate colors too. Now notice this has from 0%, which is possible, all the way up to 100%. None of these every year should equal to 100%. Okay, if there's two categories. And then we have circle graphs. You've known them as pie charts. Okay. Again, you can use, these are for categorical data usually. Okay, consists of a circular region and separate it. Circular graph shows how parts are related to the whole. Okay, so it says construct a circle graph for the information in the table, which is based on the survival and death rates of crew and passengers in the various ticket classes in the Titanic. You have first class, second class, third class, crew, and total. Survivors and deaths. Okay, notice a lot more crew died, a lot of third class. Okay, you can kind of see where all those kind of died. The entire circle represents 710 people. Okay, the measure of the central angle, which is the angle whose vertex is in the center, of each sector is proportional by a fraction. Okay, so let's see here. So if we take a circle, there's your circle, right? Now, the angle, the central angle, comes from, I take this to the center, and then there to there. Okay, right here is your central angle. Okay, this is what's known as a central angle. Yeah, I want a different color. Here we go. So from here to here. Okay, that's my central angle. Okay, and it comes from, it's a proportion of a fraction of the fraction of the percentage. Okay, remember that if I was to cut this all the way across, this would be 50, right? And I can't write the number. Okay, if I did it from here, whoops, let's say, let's do this. If I go from here to here and here to here, okay, this money right here, this would be 25%, right? That's 25%, which would be 1/4. Okay? And you guys being elementary, you're not going to go real tough in depth of these, but in terms of really weird numbers, it says the measure of the angle of the first class passengers is 202 over 710. Okay? That's 28.5% of the circle. Because the entire circle is 360 degrees, everything should be adding up to 360 degrees. You do that for all the classes. Okay, so the death of the first class, second class, third class, and crew. Okay. All right. Now, how do I figure out this? Whoops, let's go back one. All right, so how do I figure out the degrees? Okay, well, if you take, let's see here, let's be the easiest way to do this. All right, so if you take this, okay, you can take the percent, okay, so you can take the 28.5 divided by 100, okay, that's your percent, and all of that would be equal to x over 360. Okay, now that x is the degrees. There's 360 degrees. Okay, so if you solve that cross multiplication and all, you would get that number. Okay, and so you would get the number that you draw that degrees in that central angle. All right. And then this would all be put on. Here's 103 degrees, 60, 90, and 180. So this 90 is important, okay, because that 90 is almost a fourth, right? That's 90 degrees, okay? And then here are, this would be the 108 because it'd be more than 90, okay, and so forth. Notice the legend, first class, second class, third class crew. They have the different colors, and we have the death rate and the survival rate. All right, so there you go. Okay, so that is this section of 10.2. I'll be doing 10.3 here in the next day or two so that we can get you ready for you to get this homework done. Okay, hope this helps.